One sec. Hey everybody, Evan Kirstel here today with Gigamon. We're going to talk about supercharging cloud security with observability and a brand new security paradigm that looks really fascinating. Before that, let me introduce our guest, Bassam Khan from Gigamon. Bassam, how are you?
Hello, Evan. I'm doing quite well. Hope everybody else is well too.
We're doing good. Maybe introduce yourself, your team, your role at Gigamon, and then we'll dive into this topic, which I think our audience will find really intriguing.
Happy to. So I'm Bassam. I am responsible for product marketing, technical marketing, engineering here at Gigamon. My job over the past 5 years has been to understand where our customers are headed. So I spend a fair amount of my time talking to customers, one-on-one sessions, one-to-many sessions, understanding where the customers are headed, where the industry is headed, and be able to translate that to where we're headed as well. So align our company and product and go-to-market direction along with the customers. My background is in cybersecurity. It's in cloud, and MLAI is, of course, on everyone's list of things. If you're in security, you've been working in the MLAI space for quite a while. So here to talk about our new technology called Pre-cryption.
Yeah, I'm really excited to get to that, and we're going to have to start with some definitions. So let's go back to the basics. Let's talk what is encryption, decryption for the newbies who might be watching, and then we'll get into Pre-cryption. So give us a bit of a definition for these terms of art.
Happy to. So just to baseline here, encryption is a notion of taking clear text traffic and putting some level of encryption to it, some obfuscation of that traffic so people cannot see what's being communicated. Why do people do it? It's to protect sensitive information. And today, that means pretty much everything. Over 90% of internet traffic today is encrypted. Over 65% of east-west lateral traffic is encrypted as well. What happens if we don't encrypt? I can literally go into my doctor's office. While I'm waiting for the doctor to come in, I can get my laptop, put a little network sniffer in, and see what's going on, see what the machines are saying to each other, and be able to see the traffic as if it's just listening in on somebody else's conversation. Not a good thing to do. That is why people put encryption technologies into place. So that communication is passed around in a secret way. So that's encryption. Lots and lots of very valid and good reasons to encrypt. The bad news is that the threat actors are also leveraging encryption to hide their communications. So today, if you look at the modern malware and modern technology, TTP used, almost all, if not all, of the tools today use encryption to hide their insertion of malware, their lateral movement of moving malware across organizations, command and control communications, data exfiltrations. All of these are encrypted because it makes it much harder for your security tools to detect what's going on. So good use, bad use, and that is the reason why decrypting traffic before you send those to your security tools is a really important step, because that opens up the traffic and makes the tools much, much more effective in doing their job.
Okay, so thanks for setting the scene, just as a reminder. Now, talk about the game-changing Gigamon pre-cryption technology. How is it different from the scenario you just described around traditional decryption techniques or technologies?
Yeah, good question. Let me dive a little bit deeper into decryption, the notion of decryption. Not typically, 100% of how decryption works today and has worked historically is by literally sticking a tap, a sensor sitting in the middle, man in the middle, kind of an approach to looking at all the traffic going through the wire and saying, okay, I'm going to decrypt before I intercept the traffic, decrypt before I send it over to the tools. That can get very tricky. That can get expensive and complicated. The reason that can get very complicated is because I need to sit in the middle. I need to collect certificates, keys, basically, from the two parties that are having the communication, man in the middle kind of an approach. And managing the keys can be an extremely complex environment situation. And then you've got the notion of the cost of decrypting the traffic, because decryption is a really resource-intensive work. It's highly mathematical, high use of CPU memory resources to decrypt traffic. And that gets quite expensive quite quickly. So it's complex, it's expensive. And the last point here is some of the more modern encryption technologies, such as perfect forward secrecy, PFS, which TLS 1.3 is built on, even TLS 1.2 uses that technology. That makes it impossible for somebody to sit in the middle and be able to inspect the traffic. So the need for decryption is still there. It's bigger than ever, but the difficulty in decrypting traffic from a complexity and cost perspective is getting higher and higher. So today, the biggest blind spot in any organization is east-west lateral traffic that's virtual, that's not crossing a firewall. So this is what's one of our tendencies to build microsegment our networks and build segments and put a firewall between those segments to intercept the traffic, see what's going on. Great, that's great. But what about what's happening within that VM, within that application, within the containers and the pod and nodes talking to each other? That's been a huge blind spot. That's what Gigamon set out to solve based on our customers' situations, customer requests that, hey, here's the traffic that we're not looking at right now because we can't. So with Gigamon's Pre-cryption, what our customers are able to do is inspect that lateral virtual traffic that's not crossing the firewall, or even the ones that are crossing the firewall. Pre-cryption is a much, much lighter weight technology. So remember, I talked about two problems, expensive and complex. With Pre-cryption, there is no need for key management because I'll explain why in just a second. There's no need for key management. There's also no need for heavy decryption, CPU cycles being taken up, memory being taken up. The reason it's not there is because of the way we leverage virtual kernel. So Linux kernel has something called eBPF. It's a kernel level service that allows us to access the traffic without having to sit in the middle, without having to put a big fat agent that sits in the workspace of the application itself, going down the application, worrying about versions. So Pre-cryption is able to intercept the traffic before it's encrypted and be able to collect that and send it in a safe manner through a secure tunnel over to any tool that needs access to that decrypted data. So it's decryption without decryption.
Wow. Well, that is rather different than traditional decryption approaches. Tell us more about the why. I mean, why is it important for security teams to be able to see decrypted or plain text traffic today? What are the various reasons?
Yeah, so there's a ton of material out there that talks about the threats that lurk in encrypted traffic, about the tools and the techniques that threat actors are employing more and more. If you look at the latest techniques, or even going back many years, use of encryption for those three functions, which is malware insertion and lateral movement, for command and control communications, and for data exfiltration, encryption is used almost 100% of the time. So the tools that you have need access to decrypted traffic in order for them to do their job better. Can tools work on encrypted traffic just by looking at the traffic headers? Yes, there's some level of accuracy and functionality that they can do. These tools being, let's say, an NDR, network detection response tool. Can they work off of the packet level information, header information, net flow information? Yes, they can get that data and coming in. And also the third area, Evan, is their ability, these tools' ability to ingest and apply ML and AI to encrypted traffic. They look for patterns in the traffic and encrypted traffic, and their ML/AI engines are able to figure out, we're detecting some anomalous activities. It's probably something going on here. So there's some level of capability working with encrypted traffic. However, if you talk to these to our customers and talk to customers, and we talk to the vendors, they will say these tools are always more effective working both with encrypted traffic, so they can apply all those techniques, and working with decrypted traffic. This is particularly important because when an NDR is trying to put the pieces back together, it's like a CSI scene, literally, something that happened 3 months ago, threat actors came in. What did they do in my environment? When you're working with encrypted data, you don't have any visibility of what's going on inside the traffic. When you work with decrypted data, you see a lot more visibility, makes it exponentially better in putting the pieces back together, saying, aha, this is what the threat actor did. This is where they got to. This is what they were doing. This is the techniques that they used. So that is why decryption is super important in addressing these different types of threat actor activities.
Interesting. So after sort of lifting the veil and decrypting traffic, what are the best practices for SecOps teams to do next? What should they do next?
Yeah, that's a really good question. That's an area, frankly, Evan, there's not a lot of material out there. In Gigamon, we've got quite a bit of experience in handling or working with customers who decrypt the traffic and then know what to do afterwards. Decryption is not the end goal; it's a means to an end, and that's a really important fact that often gets overlooked, particularly from vendors just putting material out there saying you have to decrypt, you have to decrypt. Okay, great. What do I do when I get clear text traffic? So think about this. This is in Bassam's bank information. This is my medical records that all of these third-party tools now have access to. So it opens up a can of worms from a compliance perspective, privacy perspective, regulatory perspective, and sometimes these are industry specific. So HIPAA on one for medical, PCI for financials, and so on. So it opens up a can of worms. So should we still decrypt because it opens up? And the short answer is absolutely yes. And one of the publications, it's not quite a publication, it's actually bigger than that, say NSA advisory that was put out there, really talks about the need to go there, the need to decrypt, and also what to do after you've decrypted traffic. So if our audience wanted to Google TLS, NSA TLS advisory, it's called Managing TLS Advisory. They can look this up. It's a really prescriptive document talking about what to do once you have decrypted the traffic, once you've gotten access to clear text data. From Gigamon perspective, we offer a spectrum of different sets of capabilities that allows our customers to make sure that they're staying compliant, that privacy is maintained, that regulatory needs are met. So on one end of the spectrum is sending fully encrypted traffic to the tools. So Gigamon sits between your entire infrastructure. We make sure we're collecting all of the traffic, and we sit between that and your security and networking tools that monitor, secure, optimize, troubleshoot everything that's happening in the infrastructure. So the first simple function is to just send encrypted traffic to tools. The second function that people use Gigamon for after the decryption's done is basically sending header information, but it's not just header information like NetFlow. There are over 7,000 different metadata that we can extract from that decrypted traffic. What is metadata? Metadata is simply information about the traffic. So think about a box that you're sitting in and you're at the post office or your TSA, you're seeing a box go by. We're able to create the inventory, create the bill of material, what's inside that box, saying that this is Facebook traffic, that someone's doing some Facebook chat, so your tools know how to react to that. We can also say this is Facebook chat, but Bassam just received a file from Evan that looks a little suspicious. Why is that coming through a Facebook chat? We can say there's what's called port spoofing activity, so inappropriate use of TCP ports, crypto mining. So there's a lot of different capabilities, knowledge that we can extract out from that knowledge. It's not violating privacy in that sense. It's just creating metadata about that traffic, which is super important. Now, some tools need access to clear text traffic. So we also offer the capability of masking out privacy-related information. So our customers can say, this record or this part of a record, it's the patient's name, address, or whatever, or medical condition. My security tools do not need to see that in order for them to be effective. So they can mask out any part of the data, and we provide all the UI and all the capabilities to define what to mask out and what not to mask out. So once that's done, we are very tool specific. So our customers can choose to send fully decrypted traffic to one tool and send partially decrypted traffic to another tool. Another area is selective decryption. You can say, I'm not going to decrypt any traffic until one of my security tools says, uh-oh, something weird's going on with this host. Let's start watching that host a little bit closer. This is a key use case, by the way, for zero trust that we're finding a lot of our customers using. Rather than decrypting all traffic, they're selective decryption. They're applying selective decryption based on some indications coming from the different hosts. In that case, we would typically fully decrypt, maybe some masking, sending them a tool. The last point capability is fully decrypted traffic. So there are cases where our customers will say, this is traffic that needs to be fully inspected. So we're going to fully decrypt and send these 1 or 2 or 3 tools. So there's a whole spectrum. So again, decryption is not the end goal. It's a means to an end, and the end goal being effective inspection.
Interesting. And how else are you being asked at Gigamon to help navigate or manage all this decrypted traffic? What else can be done there?
Yeah, so there's a whole set of capabilities once you've got the decrypted traffic. So I talked about the 4, 5, 6 of the capabilities here. Now, the key question is I've got this traffic that has been decrypted for my tools to process. But what's new here, what's different here is the notion of pre-cryption. It's addressing that biggest blind spot, which is east-west. And if you talk to any organization, I've spent the past 6 months that we've been working on this technology, talking to anywhere from C-levels down to the security analyst and everybody in between. What are you doing about your lateral virtual traffic? And this is an area that's not been inspected before because, again, it's too hard to do. I can't micro segment out blind spot. So no matter how much I segment off my traffic, there's still east-west lateral traffic. I can't expect to put firewall in everywhere where there's communications going on. That just becomes ridiculously expensive to implement. And that is why this technology is catching on so quickly in the industry. It's because we provide the ability now to have your existing tools be able to inspect the traffic. So there's 2 parts to this, Evan, to answer your question. The first part is eliminating the blind spot and being able to see what's not possible to see before. The second part is the notion of metadata that I mentioned. So through deep packet inspection, we will tell you over 7,000 different attributes about that traffic. Why is this important? This is important because if you look at a log file, which your SIMs ingest, it's not giving you the level of detail. So what Gigamon is able to do through metadata is to say, yes, Bassam connected to Evan's machine. It's over port 443. That's a standard web HTTPS traffic. However, what it will not say is that even though it's HTTPS traffic, the actual communication protocol that's going over that is it's DNS protocol or SSH, secure shell protocol. So it's called the activity is called port spoofing or non-standard port use. That usually indicates really bad behavior or something that should at least be followed up on. So getting that level of context pulled out of the traffic, really important for your SIM, but also for your observability tools. So now app owners can say, hey, my application it's people are connecting to it, or my workspace, my VM, my containers, but why are they sending secure shell traffic over a web protocol or web port 443? So there's quite a bit of suspicious activity that's happening that our customers find this to be a super useful tool to look into.
Fantastic. So Pre-cryption has been received really well from the media, from analysts. Lots of positive feedback. It seems to align pretty well with modern cybersecurity strategies like zero trust as well. What else should tech leaders, IT leaders know about it, maybe that they haven't seen or heard or read?
One other really key area, Evan, that we've gotten quite a bit of feedback now, positive from our customers who tend to be the security team or the network engineering, network architect team, is the fact that they're not seeing a lot of pushback from their app owners, from their DevOps teams, from their dev teams in being able to access this traffic. Why is that? Because typically to access this lateral communications traffic, you'd have to insert an agent. So it could be like, EDR agents is a really good example, or a API security agent or anything. That has an impact on the application itself. It has an impact on the application's memory usage, CPU usage, performance quite often, or at least QA testing or compatibility testing. Is my latest CI/CD code that's coming out compatible with this latest version of the agent or the code snippet that's coming from the vendor, because it's running in the same memory space? Diving a little bit into technology here, I mentioned eBPF. So what Gigamon's doing is we're not running in the same memory space, same workspace as the application. We're running next to it in the same VM or container, and eBPF is the plumbing underneath. It's a bunch of, that's part of the kernel, but one of many kernel services is the network traffic access. So what we do, what Pre-cryption does, is if the developer says, here's Bassam's or anyone's medical record, I want to send it to a client, I want to send it to a server. Before I send it, I'm going to encrypt it. So then that application will call what's called OpenSSL library, is the most commonly used encryption library. So it calls OpenSSL library and says, hey, encrypt this, put this on the wire. So what Pre-cryption does is we allow the security team and the DevOps and the app owners to reprogram really easily. There's not any kind of programming involved. eBPF, reconfigure eBPF, not actually reprogram, it's not reconfigure is the right word. So configure eBPF to say, while they're sending the traffic, encrypting, sending traffic, before you do the encryption function, send a copy of it to Gigamon's what's called UCT, Universal Cloud Tap. And at that point, we get a copy of the clear traffic. So it's almost intercepting and asking the OS and the kernel level service to send us a copy of it. So that's our uniqueness, and that's a really cool part, because there is no decryption. There's no key management. We can support up to TLS 1.3, MTLS in the government space. It doesn't matter what version of TLS is being used. We can get a copy of it in a very, very lightweight fashion. And we're not scraping keys. We're not breaking the security level that people use with these encryption technologies. So being able to get this in a very lightweight fashion is something we're finding that DevOps teams are much more accepting of this type of technology to monitor traffic, because they actually do want their apps to be safe. They do want their security to be at a higher level. What they have been pushing back on are agents that get in the way. This is not one of those.
Interesting. Good to know. Well, next, I guess, a question is a bit of a hypothetical, and hindsight's always 2020. But with all the cyber attacks in the news recently, do you think Pre-cryption could have helped those organizations in any way?
Security, as you know, is defense in depth. We believe that Pre-cryption is a really effective part of a solid security posture with strong defense in depth technologies that's layered in there. Now, I tend to be a little bit cautious around the word, could have prevented, but you did ask, could have helped, and that answer is absolutely yes. We could. That's what Pre-cryption is there for. So remember, there's two parts, actually multi-parts to typical attack. There's the initial compromise that happens of a host. That's typically done through a firewall, through an IPS, through something that's sitting inline. Pre-cryption is not an inline technology. That's also what's really cool about it. That's how we are able to be very lightweight. So your firewalls, your IPS systems, your IDS systems in some cases are what's really protecting. That's sort of the front line. Where Pre-cryption comes in, where Gigamon in general comes in, is what happens when a host has been compromised. So my machine at home, I visited some sites, I did something bad, compromised. I bring my machine to work, and there's a way into our network. That's where Gigamon comes in, and on the monitored network, whether it's on-premises, physical, private cloud, public cloud, wherever those workloads are running. That's where Gigamon comes in and saying, hey, let's shine a spotlight on your entire network communications, not just part of it. And this kind of goes back to the old story about did you lose the keys here? Why are you looking here? Because the light's shining here. I lost the keys over there. I totally ruined that the way I said that.
I got it. Yeah.
So the notion here is that Gigamon, through Pre-cryption, we light up the entire street. So you're not forced to look where you have visibility in your traffic. We open up all of the network communications.
Good to know. And you do a lot of work in the emerging and rapidly growing multi-cloud kind of environment. I assume that you can also facilitate security across those environments too, which involve lots of scale and performance challenges.
That's a very fair statement. It's pretty safe to say, if not 100%, nearly 100% of our customers have a cloud-first strategy. They want to be 100% cloud on a single cloud platform. What I can say with certainty is 100% of our customers are some kind of a hybrid deployment. We are typically used by the largest organizations out there, the biggest banks, 10 out of 10 of the US government agencies, top government agencies worldwide. They tend to be very hybrid. Some things are running on premises the old way. They still have mainframes. They're still part of their equation. Private cloud on premises, public cloud, as well as multi-cloud. That's a very, very common scenario across the board. And the challenge that people have, and this is really what leads to blind spots being built up everywhere, is the notion, or is a fact, that every platform has a different mechanism for accessing network traffic. And they're all different, and they all work differently, and they look different. So if you look at VMware's ESXi or even NSX, even within VMware, there's multiple ways of accessing traffic. Then there's the different public clouds, and there's EKS, AKS, GKE for container access in public cloud. So as a result, the operations teams need to become experts in how to access traffic based on each of the different platforms. And that's an area that typically our customers don't want to deal with. That's where Gigamon comes in. We worry about the plumbing. So we have one product called UCT, Universal Cloud Tap, that gets built into either orchestrated using native mechanisms or using our management console, our management tool. And it is able to, having one binary, it's able to collect traffic on any kind of virtual platform, whether it's in a regular tapping fashion or a pre-cryption manner that I talked about. So that's where we come in, is the ability to not worry about the traffic access, eliminate blind spots, whether it's a single environment or any kind of complex hybrid deployment.
Interesting. Well, we're out of time. Unfortunately, I've really learned a lot. It's been intriguing chatting with you. What are you looking forward to the next weeks, month, the rest of the quarter? Any travel or events or meetups that might be of interest?
We do have a number of activities coming up from Gigamon. So one-on-one, I'm on the road quite a bit, meeting with customers. The next big event I'm really looking forward to is a Zero Trust Summit that's coming up early February. Actually, it's late February, early next year. That's Gigamon sponsored on leap year on February 29th. So keep an eye out for that. We're expecting it to be a very, very large event based on the interest that we've gotten and requests from customers about helping out with their zero trust journeys.
Well, can't wait to take a look. Sounds exciting. Thank you so much for the insight and the analysis and the great work that you and the team do. And thanks everyone for watching. Reach out to us with any questions or comments. Until then, we'll see you. Take care, Basam.